OK
然后要讲 type 1、type 2。
OK
然后最后再讲 estimation，因为我老师说就是 estimation 里面有一些 hypothesis。
OK。Guys, we need to check a bit more complex number. A bit more about complex number first. You're very confident about complex number? Okay. First, we check a question from student. We check question from student. This one. I'll make it a smaller. Oh yeah. We need to learn some knowledge first. We need to learn some knowledge first. I'll give you a random question. This A 3 minus 2i. This is A. We need to understand some idea first. This is B. 7 minus 5. You have two complex number here. If you really sketch, probably you can say this is the RE, this is IM. If you sketch it, but we don't really care. Doesn't matter. Now the question is, if we form a square, this is a square. CD. How can you find the CD? We can use transformation to work out this question. And the vectors. First idea, A is the center of rotation. AB around the center, rotate 90 degrees, gave you AD. Okay, from the graph, AB rotate 90 degrees anti-clockwise, gave you AD. Rotation 90 degrees, gave you AD. How we show this relation in complex number, this transformation in complex number. Check here, this idea very important. How we show this AB rotation 90 degrees in complex number. Check AD equals B minus A, AB equals B minus A. Rotate 90 degrees anti-clockwise, which means times by I. Why times by I? That means rotate 90 degrees. The reason here I equals cos 90 plus I sin 90. If you have a complex number Z equals R cos theta plus I sin theta, what happened Z times by I? 偶然 R cos I sin, what do you have in the bracket? Modulus argument form times together. How about the angle? All right. What in bracket? Yes, we just add them together. If you use readings, we learned e to the power of IA times e to the power IB, just e to the power IA plus B. So here, just theta plus 90. Okay, what happened? The the angle plus 90. That means rotate anti-clockwise by 90 degrees. So times by I means rotate 90 degree anti-clockwise.
What is D minus A?
D minus A. Oh, B minus A first. We don't know D, but A is 3 minus 2I. B is 7 minus 4I. A is 3 minus 2I times I. So you can rearrange to calculate the D. This question should be use similar idea. Should be similar idea for this. But try to do the question I just designed on the top. In the example, I gave you how to calculate D. You try to find the C. Try to find the D first, and then find the C. Everybody try to find the D. For the example first, later we try the question from student. Try to find the D. And just try to use calc, okay. So 4 minus 2I. So 4 minus 2I, 2 plus 4I, 2 plus 4I, 5 plus 2I, 5 plus 2I. Try to calculate the C. Try to calculate C. How you rotate this one? So you have here. Try to calculate the C. Say you can say BA rotate 90 degree clockwise.
All of it's fine. You don't pass it. I'm not checking this. The standard explanation.
So you need the BA times negative I to have BC. We have C. Not yet.
We haven't calculated BA yet, right?
BA just A minus B. So the other one, BA times negative I give you BC. BA just A minus B, like a vector. BC just C minus B. Calculate the C. What? C just equals 9? Shan, what do you have? No, not 9. Okay. Check here. And let's check out. We try to rotate vector. Now we have vector BA. Vector BA rotate 90 degree clockwise, give you BC. Vector BC. How we show this idea? BA times 90y equals BC. Is that 9 or no? Oh, not 9? Okay.
I think I did something wrong here.
Guys, this question could be AS. This question could be AS. I didn't say the common number in AS. I mean, this question could be in AS. Just like 3 minus 2i change to 3 comma negative 2. Because the point, the coordinates. Okay, for example, the question, we still use our example. 3, negative 2, 7, negative 4. Check here, 3, negative 2. That's A. 7, negative 4. That's B. Now the question asks you, if we have a CD, a square here. This is 3, negative 2. This is 7, negative 4. A, can you find CD? Change to AS now. Because that's called coordinate geometry. Coordinate geometry. Okay. Okay.
Yeah, I forgot all the rotation stuff. This is just gradient.
Oh, this one just you can say gradient. For example, CD line, you know the gradient. BC line, you know the gradient. AD line, you know the gradient, and you know the distance. AB, BC, CD, AD, they're all the same. Okay. How we work it out? Or we can just use graph. Check here, guys. What's this line? 2, right? How about here? 4, okay? Which means here 2, here 4. Do you understand? It's just the congruent triangle thing. So this is 9, 0. We have it. Okay. And this is 2. This is 4. Which means this is 5, 2. Okay. Do we have D5, 2 in the other question?
Yeah.
5, 2? 5, 2? Yeah, 5 plus 1. Okay. Just sketch graph, you know it. Because you can sketch here, they are the same. Here, 2, 4. Yes.
Where's the question now? Like the paper.
Which question? You mean the example I gave you? Oh, no, the other question. The other question from Amelia. I'm not sure where the paper from, but that's okay. The idea again. For example, hello, guys. If we change it, this is RE. This is IM. Now it's A2. Complex number. A just 3 minus 2i. B just 7 minus 4i. I really need you understand this. Everybody else suggest you understand this. AB vector times I, what you have. And BA vector, I'll just say BA, doesn't matter. BA times by negative I, what you have. DC times negative I, what you have. CD times I, what you have. Again, AB times I, what you have. AB. So the starting point is A. AB times I, what you have. 傲然。AB times I, we try to find the stuff. You got AD. AD, guys. It's like AB there, you times by I, rotate the anti-clockwise. AD. BA times negative I. BA times negative I, rotate the clockwise. What do you have? BC. Ashan. DC times negative I. Excellent. Then new CD times I. You're not Daniel? You're Daniel, okay. Oh, this guy also Daniel? You're Daniel? Okay, I always call you PX. CD times I means rotate anti-clockwise. CD times I. CD times I. CD times I. What's that? This is CD times by I. CB, correct? That's the idea. We try to use rotation times complex number about rotation or enlargement. Why? Why? For example, RC is C. Okay. Cambridge, we better use cos theta plus I sin theta. If you times 2I, what's the meaning of the transformation? Times by 2, that means enlarge by scale factor 2. Times by I means rotate anti-clockwise by 90 degrees. So times 2I is the two transformation combined. Okay? The idea, And BAAB, just B minus A. AB, just B minus A. So you combine those knowledge for the question, like you have a square or some rectangle, just do rotation. Common number pretty useful in geometry.
What is 2I if it is?
Oh, 2, if you times by 2, just R double and theta plus 90 degree. Because I means angle 90 degree. Right here. That means originally you have here, this is just R, this is just theta. But you times by 2I, doubled 2R, and the angle plus 90 degree. Okay. And you okay? Yeah. Okay, here's the idea. You understand the idea? Rotation. Now we check the question from Amelia. The question just here. 8, probably about eh, eh? Now U is 1 plus 2 root 3. That's U. Oh, U just point A. U just point A. RE, I am B 3 plus 2I. B 3 plus 2I. Okay. The third point, C, in the first quadrant, 1, 2, 3, 4. That means quadrant. And BC doubled. Oh, we know it already. BC doubled, and 90 degree. Let's see, huh? You understand? You okay, guys? No. BC equals BA times by what? 傲然
B8 times negative I. 2. Oh, the 2.
negative 2i. 2i means rotate clockwise. Negative I means rotate clockwise. 2 means double. BC just double the BA. Okay. If you understand here, wow, this 4 marks. BC, C minus B. BA, A minus B. Hurry up, calculator. Calculator C. What's that? C equals negative. Huh? What? This C look at the positive value first. How you got negative? You got negative 1?
1 plus 4 root 3.
Negative 1 plus 4 root 3. That's the real part. How about the imaginary part? 6. Amelia, okay with this question? Michael got different answer? Is the answer same? Yeah.
You could use like this in your simultaneous equations using that.
The distance of BC equals double the distance of AB. Yes, correct. And the gradient of just -1. Yeah, you can do that.
It's so complicated to solve.
Okay, let's double check Oran method. Let's double check Oran method. His method correct. Just the final answer same? Or you stuck somewhere in the middle? Okay. Guys, Oran idea. If you say just X, Y, we are revising some AS. If C is X, Y, Y minus 2 over X minus 3 times by the gradient of AB. The gradient of AB. 2 minus 2 is 3. 3 minus 1 equals 91. Why? Because perpendicular, two gradient are times together 91. So you have an equation here. That equation, the distance of BC, square root of x minus 3 squared, y minus 2 squared equals double the distance between AB. Between AB, 2 squared, 2 root 3 minus 2 squared. You have here. So the question changed to AS simultaneous equation. Simultaneous equation. Okay. Then why you have a 20 somewhere?
No, my other simultaneous equation wasn't. I didn't use the. I used the two square roots, but I didn't use a gradient one. I used like Pythagoras.
Oh. Yeah. Okay. This one you just need to solve y because y6 look easier. Okay. You guys practice back home. You can cancel the square root. If you cancel the square root, I can give you one more step. Cancel square root, 培心. What I missing here? What I miss here? Very good, because you square both sides. Guys, back home, solve this simultaneous equation to revise your algebra.
Can you do Pythagoras or just repeat of that equation?
Pythagoras. Oh, you try to find this distance.
Yeah,
use Pythagoras. I think it's repeated. Repeated. You use radian. You use the gradient. Gradient. Okay, so that's the second way. But we prefer the first way. The second way too long. Any other question? Complex number? You guys okay with the locus, loci? You okay with locus, loci? What you are doing now? Oh, so when you will try complex number? Okay. If you got mechanics question, just send to me. Replay the recording I gave you for mechanics. Yeah, I like mechanics. This is physics, but with more math there. We need to solve simultaneous equation, quadratic equation. Okay, for complex number, we double check worksheet. Just for the locus thing. Oh, William, do you understand the idea we just discussed? The complex number? Okay. Yeah, replay the recording. We always encourage students try like scholarship exam. So we might try some questions a bit weird. Number 10, I'll give you a hard copy. Okay. Just basic thing, huh? For example, the first one, what's the you finish combat number at school? Estimation? Hey, you said your school do estimation after stuff.
Yeah.
So different class change the order. Okay, that's interesting. Same school. You use different order. Okay. Okay. Oh, guys, you can use your notebook. Just try how to change the modulus and argument. Try a modulus argument. Modulus argument. Modulus argument.